Hi everyone. In this video we're going to be working on 2015 AB/BC free response question number 1. Now this is a question that deals with something going into an object and something going out of an object. So I consider this a rate in and rate out problem. So we're going to have to take account for these different factors. So let's go ahead and get started. It says the rate at which rainwater flows into a drain pipe is modeled by the function R, where R of t is equal to that. So that's going into a drain pipe. So this is my N equation. And then it says the pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by d of t equals that equation. This is my out equation. This is going in, this is going out. It says for time between 0 to 8. It says there are 30 cubic feet of water in the pipe at time t equals 0. This is probably the most important sentence, because this right here is your initial amount. So that means that the drain pipe already has 30 cubic feet of water. So we need to take account for that, because if there's water going in, well, it's going to be added to 30. And if there's water going out, well, then it'll be 30 minus that. Okay? So let's go ahead and get started with part A. It says, how many cubic feet of rainwater flow into the pipe during the 8 hour? Okay, they want to know how much amount of water flow into the pipe. So into amount is going to be integral. So for part A, you have to remember that anytime they want you to find a total amount, that's always going to be an integral. So we're going to find an integral from 0 to 8 of R of t respect to t. Now your next step is go ahead and plug this into the calculator. This is question number 1. So grab your graphing calculator, and then because it's asking us from an integral from 0 to 8, we're going to type in math. And then you can either scroll down all the way to number 9, or you can just press 9. And then you're going to type in exactly what you see. You're going to know that, well, it starts from 0 all the way to 8, and then type in R of t. Now, because this is the trig function, you have to make sure that your calculator is set in radians. So 20 sine parentheses, you don't have to plug in t. You don't have to plug in t, you can plug in x. So x squared divided by 35. Close it, and then press x because it has to match up with that letter on the inside. Press enter, and you're going to get a value of 76.57. That means that between 0 to 8 hours, 76.57 cubic feet of water are going into the pipe. So this is going to equal to 76.57, and usually round to the nearest third or 4 decimal places. So that'll be your answer. So that's your answer, part A. So then you move on to part B. It says, is the amount of water in the pipe increasing or decreasing? Now, when you see that question, the key word should be increasing or decreasing. You got to remember, what does it mean in calculus in order for an object to be increasing or decreasing? Well, what that means is that your first derivative, if it's increasing, be positive, or if it's decreasing, it's going to be negative. Well, take account for what's happening in the water. Water is going in and water is going out. Well, how much water is going in? At what rate? So for part B, it's going to be 20 sine t squared over 35. That's how much water is going in, and the amount of water that's going out is minus d of t, which is negative 0.04 t cubed plus 0.4 t squared plus 0.96 t. Okay, this is the amount of water going in, this is the amount of water going out. And the reason why I'm subtracting this is because this is going to be the total amount of water that's going in and out between 0 to 8. Now, another way you could have wrote this is just simply as R of t minus d of t. So what we're going to do is we're going to figure out the values of at 3 for R of t and the values of 3 for d. And that means we're going to plug this in. And R of t is 20 sine 3 squared, which would be 9 divided by 35 minus d of t, which then I'm going to put in parentheses and type in the entire equation, negative 0.04 3 cubed plus 0.4 times 3 squared, which is 9, plus 0.96 times 3, close my parentheses, and that's going to give me a value of negative 3.136. Remember, you should round to 3 decimal places or 4, so I'll just keep 4 for now. Negative 0.3136. This is a negative number, which means that more water is going out at time t equals 3. Therefore, the amount of water in my pipe is decreasing because it's negative. Okay? If it would have been a positive number, it meant that more water is going into it, so it would have been increasing. So since it's decreasing, I have to justify my answer, and then you can state, since R of 3 is less than D of 3, the amount of water is decreasing. And you can put at time t equals to 3. Okay? And that's part B. So anytime they're asking for increase and decreasing and you have an in and out problem, make sure you subtract the in and the out, and if it's positive, it's increasing, if it's negative, it's decreasing. Alright, so then we're going to move on to part C. Part C says, at what time between 0 to 8 is the amount of the water in the pipe a minimum? Well, there's one thing you need to take account for. If they're asking for the amount of water in the pipe that's a minimum, what is the original equation so we can actually figure out the absolute min and the absolute max? So we have to figure out the points, because we know from 0 to 8, that's the time water's going to be going in and going out. So the first thing I need to do is I need to figure out my original equation. So my original equation is this. Well, starting amount, which is 30, plus my integral from 0 to t. And 0 to t is going to be any time. So I can find the area or the amount of water that's going into the pipe. Well, what creates the equation of the water going into the pipe? Well, that's R of t minus d of t respect to t. This equation that I have right here for part C is going to be the amount of water I'm going to have after a certain number of hours. Okay? This is my initial plus how much water is going in and out at any time. So the first thing I'm going to do is, well, let's figure out a minimum. Well, to figure out minimum calculus, you got to remember, minimum or maximum is first derivative set equal to 0 to find the critical numbers. So what I'm going to do is I'm going to find my first derivative, which I already have. My first derivative is R of t minus d of t, and that's my derivative. Well, now I need to set this equal to 0. Boom. Now your next step is, well, let's figure out when it's equal to 0. We don't have to work this out. All we have to do is plug this into a calculator. So what we're going to do is grab our calculators, press y equals 2, and type in R of t. R of t is 20 sine x squared. Now, one thing you're going to notice is I'm not putting t, just put x. Divided by 35, close it, then minus parentheses and type in the entire equation for d of t. Negative 0.04 x cubed plus 0.4 x squared plus 0.96 x, close it, graph it. Hopefully we're going to graph it correct. And we're going to determine when this equals 0. Now you'll notice that it actually equals 0 on the left side. That's true, but remember, time is between 0 to 8. So I'm looking for 0 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So I don't even care about anything on the right side. I only care about that point right there. And at that point it's 0. So what I'm going to do is, since I'm kind of far, I'm going to zoom in. Press the zoom button. Press 2 to zoom in. And then I'm going to move this little thing, this little cursor, between these values so I can kind of zoom in there. So you'll notice that it crosses 0, but it also crosses another value which we're going to find. So the next value that it crosses is somewhere between 1, 2, 3, 3, and 4. So to figure this out, you're going to press second and calc. Second and calc. And you're going to type in 0, 2. And it's going to say left bound. So since I know that crosses there, I'm going to go really close to here on the left side of this 0, which is on the negative side. Press enter. I'm going to hover over to the right side of it. So what I'm essentially doing is trapping that 0 between left side and the right side. When it says guess, press enter. And you're going to get a value of 3.27. So at time t equals to 3.2716, that's when my minimum occurs. And how do I know this? Remember, since this is your first derivative, this is decreasing, then increasing. Decreasing, increasing is the minimum. Now, the one thing that I do not know is if this is my first sure my answer. And that's because I also have two other endpoints. I have an endpoint at 0, and I have an endpoint at 8. And I have my critical number as 3.2716. So what I need to actually do is I need to figure out the original amount at 0, the original amount in the tank at 3.2716, and the amount of water in the pipe at 8. Well, the one easy one is 0, because at 0, I started off with 30 cubic feet of water. But what about 3.2716? How do I figure it out? Well, you're going to figure this amount. So to find the final amount of 3.2716, you're going to plug this into this T. So that's when you grab your calculator again. And what you're going to do is you're going to put 30, because that's the original amount, plus math the number 9 again, which is your integral. And you're going to type in 0 to what number? 3.2716. And then type in R of t minus D of t. So remember, R of t was 20 sine x squared divided by 35, close it, minus parentheses, the other equation, negative 0.04 x cubed plus 0.4 x squared, which I put all in the exponent, so don't mind me. Make this a 3 plus 0.4 x squared, finally by plus 0.96 x. Okay, and then just make sure you have everything correct, and then from there make sure you put x because it's in respect to x, press enter, and you're going to get a total of 27.964. That's the amount of water after 3.276 hours. 27.9645. Now the good thing you notice is this is lower than that, so as of right now this is my minimum, but I do have to check my endpoint. You always have to check your endpoint when it says equal to. So last thing is I need to change that upper bound to 8. Now I'm not going to type in the entire equation over. I'm going to hover over, press enter, and then scoot all the way to the left, and I'm going to change that upper bound to 8. And I'm going to get a value of 48.54368. So as of right now, my three possible values, my endpoints, because you always have to check them, and the critical number that you found when you set R of t minus D of t equals 0 in the calculator, I got these three values. Well, which one is my lowest one, which is my minimum? This one right here. So therefore, your answer, the amount of water in the pipe is the lowest or minimum at t equals to 3.2716. Okay, so this was a very confusing problem, but it was one that you were able to do if you kind of understood. So let's move on to the last part, which is part D. And then D tells you this. It says the pipe can hold 50 cubic feet of water before overflowing. Okay, so the pipe can only hold 50 cubic feet of water. It says water continues to flow into and out of the pipe at the given rate until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time t when the pipe will begin to overflow. So the first thing we need to figure out is, when does it equal to 50? So we know that this is equal to 50. We want to figure out the time when it's going to overflow, so that's 50 or more. Okay, so once you have that, think about, well, how do I find the equation to figure out the amount of water into the pipe? Well, that's exactly what we did in C. We said the original amount, 30, plus the integral from 0 to some t, which that's going to be the number of hours, of R of t minus D of t respect to dt. And that's my answer. When this entire thing is equal to 50, that's when it's going to start to overflow. Okay? So once again, anytime they're asking for an original amount of water in anything, you have to take your initial amount plus the change that's occurring. Rate in minus rate out from 0 to some number, and that can calculate the amount. All right? So this was a tricky question, but it's one of those where if you study the key points and know what to look for, you're going to do a great job. All right, so thank you for watching. Let me know how it went.